So this is our review for summative number 9, and it's going to recover a little material on probability, because this is our second time testing the probability section. And then we're going to discuss right triangle trig applications, sine, cosine, and tangent. There's a section on converting from radian to degrees, and then also sector calculations. So everyone keeps telling me they're very excited for this test because they think it's going to be easy. So let's see what you think. This is a repeat. So remember, there's 3 types of probability we're going to discuss. And versus or versus this given stuff. So what I notice here is the first one is and, the second one's or. So and is where you have the total denominator. So 179 is going to be your denominator. And that's going to be true for the or as well. But the numerators are very different. So and means you go up to the table and you find that one number that represents all teachers who are both teacher and female. So female teachers is what you're looking for right there. So that's the number that goes into your fraction. And I don't mind if you guys don't reduce these. I really don't care. Or, however, is a little more complicated. You have to figure out total teachers and then total female. But then you counted the female teachers twice, so you have to subtract them one time to recover from that. So total number of teachers is 112. And then total number of females are 114. But the female teachers, these 67 girls, you counted twice, so you got to subtract them. So doing a little add, subtract on my calculator, I got 159 out of the 179. And then given female, I really encourage you guys to try highlighting, okay? Given female means you're only going to look at the data. Whoops, that's not highlighting. Try again. Given female means you're only going to look at data from the female row. So if I grab my highlighter here, that means right here. Oh, not there. Try again. Come on, highlighter. There we go. Ah, so much better when I'm... Oh, it corrected. Look at that. All right, so given female data, you're only looking at this data, so the total is now 114. And then out of that data, what's the probability that someone's a teacher? So 67 out of the 114. So I don't know if you picked up on this yet, guys, but those 3 questions were very close to each other on purpose. They were by design. So it was teacher and female, teacher or female, teacher given female. I just really want you to understand that those are 3 different probability calculations. So if you got the same answer for 2 of them, which is what some of you did last time, you should stop and think about that. All right, so one more, administrator and male. So that means my denominator is a 179. But if I go up to the chart and I find all the administrator males, it's these 7 dudes right here. So 7 out of 179. All right, for the male or administrator, I still have the 179 denominator, but I have to figure out total males, total administrators, and then subtract off the overlap. So total male was 65. Total administrator was 12, but these 7 dudes got counted twice. So what is that, 70 over 179? Yeah. And then given administrator, so I need to go back and erase all my highlighting. You're not going to be asked to do more than 1 set of problems on the test, so go ahead and highlight at the end there. But I can erase, so I'm going to do that. So it says given administrator, so you got to highlight all the administrative data. And using that data, I see the denominator is now a 12. What's the probability that it is a male? That was 7 out of 12. So again, 3 very similar questions, but the and, or versus given, 3 different calculations. So watch out for that. And this question, yeah, there's a little bit of reading, guys, but you just got to compare the ratios. So Papa John's, whoops, is 48 out of 110. So what I need you to do is 48 yeses out of 110 total surveys and figure out the percentage to that. So that's like roughly 43.6%. So for Pizza Hut, that was the 42 out of 91. So 42 yeses out of 91 surveys gives us approximately 46.2%. And then Domino's is 23 out of 73. So that's 31.5%, roughly. There we go, 31.5%. So you're supposed to choose 2 of the most popular pizza chains. So Papa John's and Pizza Hut have the 2 highest. And that's what I think your work should look like on that question. Guys, some of you didn't show any work and you just wrote down 2 answers, and I couldn't really give you any decent score, even though you might have been really close to the right answer. So let's just get it right this time. All right, this is a new one. Well, it's not. It's from geometry, but it's a new one for our testing. SoHCA. What do they mean? So the acronym SO means the sine of your angle is the opposite leg over the hypotenuse. CA means the cosine of your angle is the adjacent leg over the hypotenuse. And then TOA means tangent of your angle is opposite, there we go, over adjacent leg. So you're going to need to write those formulas down. I will give you the acronym SoHCA, TOA, but you have to know what that means. And you also have to be able to fill out your picture and then set up your trig properly. And then you have to know how to type it in the calculator. So first of all, if you have a calculator, please check that it's in degree mode. If you're in radian mode, you're going to get some really weird answers, and hopefully you'll notice that they're weird and you'll fix it. Alright, so we have a hot air balloon. You know I'm not going to draw this picture, guys. No way. Alright, at least it's not a lighthouse. Hot air balloon. And it says the angle of depression is 20.5. Now, that one always confuses kids because the angle of depression is up in the sky, but it's not even in your triangle. So this angle of depression is the same thing as this angle of elevation. So I'm actually going to draw that 20.5 down here. And that's the angle I'm going to center my math around. And then it does tell me some more clues. The altitude is 90 meters, so that's how high up it is. And they want to know the horizontal distance between the balloon and the landing spot. So they want to know the horizontal distance, which is here to here. So I know I'm not technically standing here, but pretend you are. According to this angle, this is the adjacent leg, and this is the opposite leg. So we're going to be setting up a tangent ratio, and this is part of your skill. I'm going to want to see your ratio. So it's tangent of your angle is the opposite leg over the adjacent leg. And I keep having kids ask me, Abrizo, when do I multiply, when do I divide, what do I type in my calculator? I cannot answer that for you. You have to know what to do, guys. This is just a cross product. So you end up having x times tangent of 20.5. I'm just on my paper right now, equals 90. And now I can see what I'm supposed to type in my calculator, because if I'm solving for x, I'm going to divide this tangent of 20.5 over. So please don't bother asking me that on a test. I cannot answer that for you. You have to know. That's actually the skill. So typing this in my calculator, I already typed it. I got 240.7. It's the label meters. So I'm going to be looking for a diagram that is all filled out appropriately. I'm going to look for a trig function that matches the diagram, and then obviously the right answer. So we have a small airplane flying at an altitude of 2,000 feet. Cool. Totally. Alright, airplane's up here. Alright, I'm not going to draw it. I'm not going to do it. Okay, altitude of 2,000 feet. That's height. And then the pilot plans to start the final descent, and the horizontal distance is 2 miles. Now notice they converted that to feet for you because you do have to have the same unit of measure. And they want to know the angle of depression. So remember, angle of depression, while it is right there, that's not part of my triangle. So what we need to find is actually the angle of elevation, which is the exact same thing. So this is the angle that I'm curious about, and that is where I'm going to center my math around. So according to that being located at that angle, this again is my adjacent and opposite. So we have another tangent. Tangent happens a lot on real world problems because those are the measurements that we can come up with easily as a vertical and horizontal distance. So tangent of, I'm going to use theta, our new friend theta, of the angle that I don't know, is opposite over adjacent. Oops, 10,560, there we go. And then I'm trying to solve for theta. And it's trapped inside of a tangent function, so remember the way we undo a tangent function is we apply the inverse tangent. Of course to both sides of the equation. This one just cancels, and this is what you type. So inverse tangent of the ratio gives me, and it shouldn't be a huge angle, guys, it's an angle of descent on an airplane, so 10.7 degrees is what it came out to. Sounds appropriate. Alright, this one's fun. So Dave here, he's measuring the height of the fire station, And it's kind of a halfway filled in diagram, so let's finish. Angle of elevation to the top is 22 degrees. So angle of elevation is down here in the ground looking up, but in this case it's from his eye level. And then he's standing 35 meters away, so right here is 35. And once again, we have a tangent ratio, because this is opposite of Dave, and this is adjacent to Dave. So we're going to set up the tangent of 22 degrees equals opposite over adjacent. And again, I cannot tell you what to type in your calculator, that's on you. So this is a cross product again. And we end up with x equals 35 times the tangent of 22. If you typed it in the other order, that's fine. Just make sure you close your tangent parenthesis. And then when you get that on your calculator, let's see, it came out to 14.1 meters. But that's not the end of the problem, because that's just the height of x of this triangle. Well, Dave was not laying on the ground when he measured this. His eye level from here to here is 1.9 meters above the ground. So what I need to do next is add the 1.9 meters, and then I get, what, 16.0, right? I think the blank is somewhere else on the paper. Sorry. 16.0 meters is how tall that building is. All right. Everyone was real excited to find out that this was a whole score on your test, but be careful, because I don't want you to get confused. So first thing I want you to remember is, what is the simplified conversion, unit conversion that we're going to use for radians and degrees? So remember, we use pi radians is 180 degrees. It is not wrong to say 2 pi equals 360 degrees, but this is the simpler version, so that's the one that we use. Alright, so remember, when we're converting to radians, I want to have my answer look like something with pi in it. So I'm going to multiply by pi over 180, which if I just kind of push those together, I have 220 pi over 180. But no math teacher is going to be happy with that answer, right? Got to simplify this coefficient, and you get 11 pi over 9. Notice my answer is in what we call in terms of pi. So it says leave in terms of pi. I do not want decimal answers of any sort here. I need a pretty trig answer. This is a big kid answer, okay? So same thing here. We're going to multiply by pi over 180, which gives me 170, hello, pi over 180, which reduces to, reduce this, 17 pi over 18. Alright, and then this one, multiplying by pi over 180 again. So, and no, I'm not going to give you this conversion, guys. You have to know this one, please. It's like the only tricky thing on this section is just knowing the conversion, so. Reduce this coefficient, and we get, let's see, I already did this one, 73 over 36. So this is 73 pi over 36. Now, guys, when I keep this, I didn't reduce that in my head. I just entered that fraction without the pi on it, of course. So I suggest you do the same. You know, there's no sense in stressing you out by trying to do mental reduction when you don't have to. All right, this next section is the opposite. I have radians and I want to convert it back to degrees. So the idea is, if you don't want radians anymore, your pi's need to cancel. So that's why we're going to put pi in the denominator this time and 180 in the numerator. And then look at this fraction here. The pi's cancel, and then you just type what you have. So you could type 7 divided by 2 times 180, literally just like that. And you'll get the right answer. Some people like to multiply across the tops and divide by the bottoms. It doesn't matter. I really don't care, guys. It comes out to 630 degrees, though. Please remember to put a degree symbol since it is degrees. All right, same thing here. I want to get rid of the pi, so multiply by 180 over pi. Pi's are gone. And you're typing 5/3 times 180. And you get, what, 300? Yeah? Degrees, please. And then we're going to multiply by 180 over pi. Pi's are gone. Oh, let's see, 330, I think. Because it's 11/6 times 180. Yeah. So with a little bit of studying and brushing up on that formula, guys, that should be one of the easiest sections I think we've ever taken. So please get a 5. I have no intention of retesting that section. This section is important to us. It's on our post-test. Some story problems come your way, and we have to remember the formulas, right? So the formula is going to be given to you. in the problem. But what the variables are is not given to you, so you have to know what those represent. So S, for some reason, represents arc length. And that's, distance around a part of a circle. So you're going to circle, and then we're going to have a central angle. We'll talk about that in a second. Okay, not like that. And then the arc length is the distance of the arc right here. So it's not the full circumference, it's just part of it. And the formula is going to be given to you. R represents the radius length of the circle. Theta is our central angle, but this is the weird one. Your central angle has to be in radians. Has to be in radians. Has to. And then A represents the area of the sector, which is pretty self-explanatory, right? It's the area of this little pizza slice. So this question is unusual because it's not a pizza slice, it's a whole bunch of circles. Because the minute hand on a clock is 11.5 inches. That's their way of telling you the radius. This is the radius. But keep reading. The minute hand travels how far from 7 a.m. to 1 p.m.? So in an hour, the minute hand makes one full clock rotation. So how many hours have passed here? Let's see. That's 6 hours, right? So it's made 6 rotations, or 6 revolutions. So when I go to figure out theta, I know it's supposed to be my angle, but it's in radians. So I think about, okay, one circle is 2 pi radians, right? But you made 6 circles, 6 rotations. So the angle that your minute hand rotated is actually 12 pi's. And it has to be in radians in order to use this formula. So that's the theta we're going to be using. So now I go back to my formula I was given, which is S equals R times theta. R is 11.5. We just figured out our theta was 12 pi. Don't lose the pi, by the way. And then I think decimal answers are the way to go here, guys. They don't really make sense if you leave them in terms of pi, so let's go with 433.5 inches. So big key there is this part right here, where when you go to find theta, it's 2 pi radians times how many rotations you've done. So you have to figure that out by counting the hours. That's all. The dog poop question. Alright, so we got a puppy chained to a post who has a 25-foot chain, and he can rotate 120 degrees. Okay? So this angle here is 120 degrees, notice. And the chain itself is 25 feet long. But remember, this is like a part of a circle. So when I go to ask you, like, what's your radius? Well, clearly the radius is the 25 feet. The chain or the leash is the radius. So we got a problem, though. Our angle currently is given to us as 120 degrees. And we were just told we can't use degree measure for the angle of theta. So you need to convert 120 degrees to radians. So go back to the last section where we converted to radians. Let's multiply it by pi over 180. And let's see, 120 over 180 is 12 over 8, so that's 2 pi over 3. That is the theta we're going to be using. So 25 is the radius. All right, let's go. Area equals 1/2 times our radius. Don't forget to square it, though, in this formula. And then times, we just found this guy, right, to be 2 pi over 3. So I'm going to type exactly that on my calculator. Please practice typing this. 1/2 times 25 squared times 2 pi divided by 3. And decimal answer works for me. I got 654.5. And then it's feet, but it's area, right? So it's feet squared. There we go. All right, I don't know what you think about that test, but I'm hoping for a lot of 5s here. Good luck.